Hey there, we are on lesson 29, session 2, develop, classifying two-dimensional figures. The learning target for this lesson is I can classify two-dimensional figures in a hierarchy based on their properties. To start today, name two categories each shape belongs to. Is one category a subcategory of the other? Pause and figure it out, and then press play again to check your work. So number one is a triangle, and a subcategory that it belongs to is equilateral triangle. Number two, rectangle, and a subcategory that it belongs to is square. And number three, polygon, a subcategory of that is it is a quadrilateral. Try it, page 591. Sort these shapes into the Venn diagram below to show the relationships among parallelograms, squares, rectangles, rhombuses, and quadrilaterals. Use at least one shape in each region of the diagram. Classify the shapes by labeling each region with the category name. I would like you to go back through and figure out what is the problem about, what are you trying to find out, and what information is important. Press play again as soon as you have your answer. So the most general category is quadrilaterals. Quadrilaterals are four-sided figures. All of these shapes are quadrilaterals, so that is the most general. Inside quadrilaterals, parallelograms is a subcategory. It's more specific. And inside parallelograms, we have two more subcategories, rhombus and rectangles. And then we also have squares. Quadrilaterals is the most general, so all of the shapes fit inside the quadrilateral circle. Inside of quadrilaterals, we have the parallelograms, and then rhombuses, squares, and rectangles fit inside of parallelograms. Squares fits inside both rhombus and rectangle because rhombuses have two pairs of parallel sides and four equal sides. And so squares are a kind of rhombus. And rectangles are quadrilaterals that have two pairs of parallel sides and four 90-degree angles, four right angles. So squares are both rhombus and rectangle. A and B are these shapes right here. And so they are quadrilaterals, and A doesn't actually fit in any other category, so it's on the outside here. B is a parallelogram, but it's not a rhombus, and it's not a square, and it's not a rectangle, so it's outside here. Now if we look at E, E is just a rhombus. It's not a square or a rectangle. And looking at C and F right here, C and F, those are both rectangles, but they're not squares and not a rhombus. And then D is the one that is a square. Now, this one, letter D, is all of these. It's a quadrilateral, a parallelogram, a rhombus, a rectangle, and a square. So it is inside all of the circles. Model it, compare strategies. You can use a table to compare properties of the categories of polygons. So if you need to refer back to this part of the video to look back on this table, or this is also in your book on page 592, this could be very helpful for you to look back on when you're doing your assignment. You can show the relationships among the categories with a Venn diagram. Two regions of the Venn diagram are labeled, and three of the shapes have been classified by placing them into the diagram. Write the remaining category names and the letters for figures C, D, E, and F in the diagram. We're looking at the same shapes that we looked at before, those shapes that are on top of at the top of page 592. So we have rhombus, which is shape E. A rhombus is a parallelogram and a quadrilateral. Rectangles C and F are also quadrilaterals and parallelograms, although they aren't necessarily rhombuses. And then squares, which is shape D, fit inside all of the categories. All squares are rhombuses. All squares are rectangles. All squares are parallelograms. All squares are quadrilaterals. But not all rhombuses are squares. Not all rectangles are squares. Connected. This is at the top of page 593. Number 1. Look at the quadrilaterals column in the table and the placement of shapes A and G in the Venn diagram. Why are shapes A and G placed in the outermost oval? Well, quadrilaterals are the most general category. The only property in the table that shapes A and G share with the other shape is the property of having 4 sides. Number 2. Explain how the Venn diagram supports this statement. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. The oval for parallelograms is inside the oval for quadrilaterals. A parallelogram has all the properties of a quadrilateral, but a quadrilateral does not always have all the properties of a parallelogram. Number 3. Look at the table. Which categories share the properties listed for parallelograms? The categories that share all the properties listed for parallelograms are rectangle, rhombus, and square. How is this shown in the Venn diagram? The ovals for rectangles and rhombuses and the regions for squares are all completely inside the oval that is labeled parallelograms. Number 4. Look at the table. Which properties are not shared by rectangles and rhombuses? The properties not shared by rectangles and rhombuses are 4 right angles and 4 sides of equal length. So rectangles have 4 right angles and rhombuses have 4 sides of equal length, but not all rectangles have 4 sides of equal length, and not all rhombuses have 4 right angles. How is this shown in the Venn diagram? The 2 ovals overlap, but one is not totally inside the other. Number 5, look at your Venn diagram. Why is shape D inside all the ovals? The square has the most properties. Squares are a subcategory of all the other categories. Number 6, reflect. Look back at your try it, other strategies, and model it. Which models or strategies do you like best for classifying 2-dimensional figures, and explain? So you might identify using the table, or maybe you like using the Venn diagram, or perhaps you like the tree diagram that we did in the last lesson. Number 7, mathematicians define trapezoids in 2 different ways. Trapezoids are quadrilaterals with exactly 1 pair of parallel sides. Trapezoids are quadrilaterals with at least 1 pair of parallel sides. Write exactly 1 pair or at least 1 pair to show which definition of trapezoid was used to make each Venn diagram below. I would like you to pause and write down your answer and then press play to check your work. So in the first Venn diagram, I see that trapezoids is on the outside, all parallelograms are fitting inside trapezoid, and all rectangles fit inside parallelograms. So that tells me that this shows us that it has at least 1 pair of parallel sides. On the other Venn diagram, we see that parallelograms are in this circle here, and rectangles are all inside parallelograms, but trapezoids are over on the side here, and it is not overlapping at all. So that tells us that that's the definition of exactly one pair of parallel sides, okay? Because if it has at least one pair of parallel sides, like the first one, then it could possibly have two pairs of parallel sides, which would make it a parallelogram. And it could also make it look like a rectangle. But if it has exactly one pair of parallel sides, like in the second Venn diagram, that means the other sides are not parallel, which means that it cannot be a parallelogram or a rectangle. Number 8. Sort these shapes into the Venn diagram based on properties of having parallel sides and having perpendicular sides. Write category labels for the two ovals. I would like you to try this on your own and then press play to check your work. So this category I'm going to call shapes with parallel sides. And the other circle or oval, I will call shapes with perpendicular sides. And if we look at these shapes here, A has parallel sides, B has parallel sides, C has parallel sides, and F has parallel sides. D absolutely does not have parallel sides. This is perpendicular. And E has one pair of parallel sides, but the others are not. So we're going to fill it in like this. E, A, and C have all parallel sides. D has perpendicular side with no parallel sides. And then B and F are both. They'd have both parallel sides and perpendicular sides because these two sides here on B are perpendicular, and on F they're also perpendicular, but they're parallel as well, so they fit into both. All right, your assignment for session 2 is pages 595 and 596 in the book. As always, please let me know if you have any questions. Have a wonderful day.